Have you ever wondered what happens when a star collapses under its own gravitational force? The result is a cosmic phenomenon we call a black hole. These enigmatic entities are the ultimate endpoint of stars that have burnt out and collapsed under the weight of their own gravity. They are the celestial equivalent of a drain, where not even light can escape their pull. Imagine an object so dense, so heavy, that it bends the fabric of space and time around it. That's a black hole for you. These cosmic curiosities have been the subject of countless studies and theories, yet they remain one of the universe's most intriguing mysteries. The more we learn, the more questions arise, pushing the boundaries of our understanding. So prepare to embark on a journey to the edge of the known universe. Today we're diving into the abyss to explore the fascinating world of black holes. So how does a star give birth to a black hole? It's a process as intriguing as it is explosive. Let's start with the life cycle of a typical star. A star begins its life in a nebula, a vast cloud of gas and dust. Over millions of years, gravity pulls the gas and dust together to form a protostar. As the protostar continues to accumulate mass, pressure and temperature in its core increase until nuclear fusion ignites, marking the birth of a star. Most of the star's life is spent in a stage known as the main sequence, where it burns hydrogen in its core to produce helium. This process releases an enormous amount of energy, causing the star to shine brightly. However, like all good things, a star's main sequence doesn't last forever. Once the hydrogen fuel in the core is exhausted, the star expands and cools, becoming a red giant. But the story doesn't end here. The star begins to burn helium, thus creating heavier elements such as carbon and oxygen. For stars of a certain size, this process continues until the core is primarily iron. Iron, however, cannot be fused to release energy. As a result, a delicate balance is disrupted. The outward pressure from fusion can no longer counteract the inward pull of gravity. This is where things get explosive. The core collapses under its own weight, triggering a supernova, an astronomical event that briefly outshines an entire galaxy. The outer layers of the star are blown away, but the core remains. If the core is massive enough, gravity continues to compress it until it becomes a point of infinite density, known as a singularity. This singularity, surrounded by an area from which nothing, not even light, can escape, is what we call a black hole. So from the ashes of a dying star, a black hole emerges, ready to influence the space around it in profound ways. But what makes a black hole a black hole? Let's dissect this cosmic monster. A black hole, at its most basic, is a place in space where gravity pulls so much that even light cannot escape. The gravity is so strong because matter has been squeezed into a tiny space. Now, when we delve deeper into the anatomy of a black hole, we'll find three key components: the event horizon, the singularity, and the accretion disk. Let's start with the event horizon. This is the point of no return. Any matter or light that crosses the event horizon is pulled inexorably into the black hole, never to return. It's like the ultimate roach motel. Everything checks in, but nothing checks out. Next, we have the singularity. This is the heart of the black hole where all its mass resides. It's a point of infinite density and almost unimaginable smallness. While we're not quite sure what happens inside a singularity, it's safe to say it's not somewhere you want to be. Finally, there's the accretion disk. This is a swirling disk of matter that spirals into the black hole, like water going down a drain. This matter is heated to extremely high temperatures and emits huge amounts of energy, including visible light and X-rays. In fact, this is why we can detect black holes, even though they don't emit light themselves. Now, the gravitational pull of a black hole is nothing short of incredible. It's like the world's strongest magnet, attracting everything that comes too close. This pull is so strong that it bends not only space but also time, a phenomenon known as time dilation. So, with the event horizon as its bound singularity as its heart, and the accretion disk as its visible face, and the immense gravitational pull as its force, a black hole is indeed a cosmic monster. It's a place where the laws of physics, as we know them, break down and the universe reveals its most extreme side. With these elements, a black hole becomes an astronomical force to be reckoned with. What happens when a black hole flexes its gravitational muscles? The effects are as fascinating as they are terrifying. One of the most startling effects is something called spaghettification. Now, as delicious as that sounds, it's not something you'd want to experience. Spaghettification is what happens when something gets too close to a black hole. The extreme gravitational pull of a black hole stretches and distorts any object that approaches it, squishing it into a long, thin strand like a piece of spaghetti, hence the term spaghettification. Everything from stars to planets, even light, can't escape this gravitational kitchen. But black holes don't just distort matter, they also distort time. This is due to a mind-bending concept called time dilation. According to Einstein's theory of relativity, the stronger the gravity, the slower time passes. So, near a black hole, where gravity is incredibly intense, time would seem to almost stand still. This means if you were to watch someone approach a black hole, it would appear as though they were moving in slow motion, and eventually, they'd seem to freeze entirely. Then there's the intriguing theory of wormholes. Some physicists propose that black holes could potentially lead to other regions of the universe, or even different universes altogether, acting as shortcuts through space and time. However, it's important to note that this is purely theoretical. No evidence has been found to support the existence of wormholes, and the laws of physics as we understand them today suggest that any wormhole would collapse almost instantly. Indeed, black holes are full of paradoxes and mysteries. They're regions of space where our understanding of the universe is pushed to its limits and beyond. They're cosmic laboratories, testing the very fabric of reality. In the vicinity of a black hole, the laws of physics as we know them seem to twist and turn in bizarre ways. Black holes are not only a scientific curiosity, but have also captured the imagination of pop culture. They've become a staple of science fiction, pushing the boundaries of our imagination and understanding. These cosmic entities, with their gravity so strong that not even light can escape, have been leveraged in many creative ways. In the world of cinema, black holes often serve as portals to other dimensions or time travel conduits. Movies like Interstellar and Event Horizon have played with the concept of black holes, creating mind-bending narratives that challenge our perception of reality. These films often depict black holes as something to be feared, yet they also symbolize the infinite possibilities of the universe. Books, too, have used black holes as plot devices. From classic science fiction novels like A Wrinkle in Time to modern works like The Three-Body Problem, authors have exploited the mysterious nature of black holes to craft compelling stories. On television, black holes have been featured in numerous series. Star Trek, for instance, uses black holes as shortcuts across the vast expanse of space, while in Doctor Who, they are terrifying forces of destruction. In all these mediums, black holes serve as a symbol of the unknown, a metaphor for the ungraspable vastness of the universe. They invoke both fear and fascination, reflecting our human desire to explore the uncharted territories of existence. Whether in science or fiction, black holes continue to mystify and captivate us. So there you have it, the cosmic enigma that is the black hole. Born from the dramatic death of massive stars, these celestial phenomena are as fascinating as they are mysterious. They begin their lives in tremendous supernova explosions, creating a gravitational pull so strong that nothing, not even light, can escape. We've delved into their anatomy, from the event horizon, the point of no return, to the singularity, the one-dimensional point where gravity becomes infinite. We've also touched upon their effects, the way they warp space and time, creating what scientists refer to as space-time curvature. And let's not forget their ability to spaghettify objects, stretching them into long, thin shapes due to their immense gravitational pull. But black holes are not just scientific curiosities. They've made their way into our culture, featuring in books, movies, and even music. They've become symbols of the unknown, the unexplored, and the infinite, fueling our curiosity and igniting our imagination. As we've journeyed through this video, I hope you've gained a deeper understanding and appreciation for these cosmic anomalies. They are more than just objects in space. They are reminders of the vastness of the universe and our quest to understand it. As we continue to unravel the mysteries of the universe, who knows what more we'll learn about these intriguing celestial bodies. For now, we leave you with the awe-inspiring wonder that is the black hole.